Hello class! In today's video, we're going to be walking through the counting by weighing activity. First, you might have seen those competitions where they have a large container and some items in it. For example, a big jar that has M&Ms. And then it's a competition to say how many M&Ms are in this jar. And a whole bunch of people write their estimates on the slips of paper, and whoever gets closest to the correct answer wins a prize. Most often it's that jar of M&Ms. Today we have a similar task. Here is a bag of white rice. I am interested in knowing how many grains of white rice are in this bag. So first, I'd like you to make an estimate. Second, how could we figure out the number of grains of rice in this bag? So this is following along on your page. Again, the purpose of our lab, to determine the number of items in a sample without counting them. I want to know how many grains of rice are in that bag without counting them. Go ahead and answer number 1 and 2. Now, for number 2, how can we most quickly estimate the number of grains in the bag? Well, if I know the mass of a small sample, say 10 grains, and if I know the mass of the entire sample, and if I can do a comparison between those two, then I'll be able to figure out how many large grains of rice I have. So that is the process we're going to step through, and this is a process that you will be doing shortly in class. So follow along for the procedure. You will not have a lot of time to dawdle to collect your data. So you are taking 3 measurements when you get to your balance, and I will walk through that procedure in a moment. I would like you to add these 3 things somewhere on your page. You will need the mass of an empty cup, the mass of the cup and 10 pieces, and the mass of the cup and your whole sample. I will step through that procedure for rice. You will also need to take those measurements for your sample. A few changes that I have on this page. First, the options are pinto, white, lima. There is a brown rice option as well. Please include your cup number. And those same 3 things, the mass of the empty cup, mass of the cup and your 10 pieces, and the mass of your cup and your whole sample. Please include a measurement for those 3 masses. Once you have those 3 masses, take a seat so someone else can use your balance. These are the steps you will need to follow in order to figure out how many grains of rice are in this bag. Or, in your case, when you do this individually, how many beans, or how many rice, or how many items are in your container without actually counting them. Some balance etiquette. First, do not just pick up some sample and put it directly on the pan. That is not good etiquette. It's not good for the balance, it's not good for your samples, and in chemistry, some of the things that we handle you can't even pick up with your hands. You always need a container between your sample and the balance pan. Now, your container has a mass. In the case of our red cup, we've got the 10.68 grams. Because you will need to share your balances, please write down the mass of your cups, because if a group comes in while you're halfway through and needs to borrow your balance and they hit 0 to zero everything off, then it'll mess up all your data. So just write down all of the masses that we take. So, step 1, put an empty cup on your balance. And you need to write down that mass. So that is a mass of 10.69. Then, you are going to add 10 pieces of your sample to the empty cup. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So there is my 10 pieces. Write down that mass as well. we have 10.96. Now, you'll notice my balance keeps changing numbers. It's jumping between the 9.6 and the 9.7. Write the number that it stays on the longest, sometimes the average, or the one that you saw before it kept changing. So it went back to the 9.6. That's what I saw originally. I'm going to put 10.96, and for the sake of time, I'm going to keep it that way. My balance might change numbers just because they're old balances. Now, to find the mass of those 10 pieces, we would subtract off our cup. I will show how to do that later. Next, we will need a mass of our entire sample. So this entire bag is poured into my cup. There's all of my grains of rice. Our mass of our entire sample is 142.25. Before you leave your station, you need to return everything to how you found it. So I'm going to pour my rice back in the original container. Make sure there's nothing in my cup. And I'm going to leave everything back at my station. Those are the steps you need to follow. Now I want to step through the calculations that we had for our procedure. So first, the mass of our empty cup, recall that it was 10.69 grams. The mass of our cup and our 10 pieces was 10.96 grams. And the mass of our cup and our entire sample was 142.25 grams. Those were the masses we collected during our procedure. Now, for the mass of our 10 grains of rice, we have here our 10 pieces of rice and our cup. So in order to get our value here, we have to subtract off the 10.96 minus the 10.69 in order to get just the mass of our 10 pieces. You need to show all of your work. So that's why I'm showing everything here, so that when we go back, you can do this on your own. So 10.96 minus 10.69 equals 0.27 grams. That means that 10 grains of my rice was 0.27. The average mass of 1 grain. In order to calculate this, we're going to divide by how many grains we had. So we had 0.27 grams for 10 pieces, and I want to divide off my 10 pieces because that will give me each individual grain of rice. So on average, my grains of rice had 0.027 grams. Now, to calculate all of my grains in my bag, I had a total of my entire sample and my cup of 142.25. So first, let's subtract off my cup. So 142.25 grams minus my cup mass, 142.25 minus 10.69 gives me 131.56. So all of my grains of rice had a mass of 131.56 because I subtracted off the amount of my cup. Each grain of rice is roughly 0.027. So if I take my total, so this is my total mass of all my grains of rice, and I divide it by my 27 amount for each grain, That should give me how many total pieces I had. 131.56 divided by 0.027 equals 4,872. I'm going to add in 0.6 just to be my decimal. That was pieces. So roughly there are 4,872 pieces of grain in this bag. That is an estimate. The reason why it's an estimate is because every single individual grain of rice is not identical to the next grain of rice. So we might be a couple off, like maybe 50 or so off, just because each grain of rice is individual. But we took an average, so that gets us a pretty close estimate. Now it's your turn. You're going to follow those exact same procedures, those exact same measurements that we just did together. For your own cup, you'll work in partners. Your options are pinto beans, so the little brown speckled ones. There are white beans. These are the smaller beans that are about the size of a pinto bean. There are lima beans. These are also white, but they are considerably larger. And there's some brown rice. Please give me your cup number. Check with the sub for whether your final answer is close. Be quick with the balances because you do need to share the balances with those around you. And make sure that you have your mass of your empty cup. There are blue empty cups provided to put on the balance. Again, do not put your sample directly on the balance. Please use the blue cup. Please take the mass of the blue cup. Next, let's move on to the back page. So, first, relative mass. What is it? If we break down this term relative, if you think of your relatives like your cousins, they're related to you, so you have similar characteristics to them because you're related by blood. In this case, relative, we're going to use that to mean a comparison. So we can compare you to your brother, you to your cousin, you to your aunt, or in the case of what we're using, we're going to compare beans to rice, lima beans to rice, the pinto bean to the lima bean. We are comparing different substances. And what we care about here is that we're comparing their mass. So when I talk about relative mass, this is a way to compare. Again, we have that comparison component. A way to compare the mass, well, earlier we figured out a mass was the amount of matter between two different substances. A way to compare the mass, which is our amount of matter, between two different substances. Example 1. How much heavier is the pinto bean than the grain of rice? So here we are again, we've got our pinto bean. We are comparing it to a grain of rice, and I want to know how much heavier, so I care about the mass. Well, in order to do this, we're going to do a ratio. And we use our ratios for those comparisons. So I want the mass of just one pinto bean, and I'm going to make a comparison by dividing the mass of one grain of rice. And in this case, I'm going to use the white rice that we had used earlier as a class, not the brown rice that some of you had in your cups. So the mass of one pinto bean to the mass of one grain of rice. These are the averages. So if we look back to the white rice that we had, an average mass of 1 grain of white rice was 0.027. That's the number I'm going to use for my mass of 1 grain of rice. I'm using the average mass, 0.027 grams for my rice. Now, what about my pinto bean? Well, some of you in class did the pinto bean, so you could use those numbers. I just did it now for my own peace of mind, where I measured out 10 pinto beans, took that mass divided by 10. I have each pinto bean being about 0.03. So that's the number that I'm going to use. If I took 10 pinto beans divided by 10, that's what I got for its mass. So 0.3 divided by my 0.027 gives me about 11. So that means that my pinto bean is 11 times heavier than my grain of rice. So pinto is 11 times heavier than rice. I could also say it like this, that the mass of 11 grains of rice is equal to 1 pinto bean. It would take 11 pieces of rice to be equal to 1 pinto bean. And we can shorten this sentence up so that 11 grains rice equals 1 pinto bean. Based off of that calculation, I would like you to try example 2 and 3. So we're comparing the lima bean to rice. When I did my measurements, I had each individual lima bean being about 1.7 grams. So that was my average for 1 lima bean. Again, stick with our white rice that we had, so the 0.27 number. And then for oxygen and hydrogen, those numbers are given to you. So take a moment, calculate example number 2 and number 3. Now let's go over my answer. So if I had 1.7 grams as the average for 1 lima bean, divided by my 0.027 grams as the average for 1 grain of rice, then I got 62.96, which is about 63. So your lima bean is 63 times heavier than your rice, which means that if you had 1 lima bean, it would take 63 pieces of rice in order to have the same mass. Next, if we took our amount of oxygen, divided it by our amount of hydrogen, because we're comparing oxygen to hydrogen, so oxygen to hydrogen, divide those numbers, we get 16. So that means O2 is 16 times heavier than H2. Another way to say that is we could say 16 molecules of H2 has the same mass as 1 molecule of O2. All right, so oxygen, 16 times heavier. Why do we care? Well, if I look on the periodic table, hydrogen has a mass of about 1. Oxygen has a mass of about 16. So when they were building the periodic table, when they were trying to find the masses of all these elements, what they did is they did it by relative mass. So they would have a certain amount of hydrogen, a certain amount of oxygen. It shows here that we've got 1 liter. So if we've got 1 liter of oxygen, we can take that mass. 1 liter of hydrogen, take that mass. And if we divide those, if we compare those, if we find the relative mass, we can get that it's 16 times heavier. So that's how they came up with these numbers on the periodic table. The atomic mass, keep in mind these are averages for all of their isotopes. Your average of oxygen is 16 times heavier than the average of hydrogen. The numbers on your periodic table work out a little bit more exactly than the averages of our rice and our beans. Again, your molecules are all identical, so they weigh the same. 1 molecule of oxygen would weigh the same as 1 molecule of oxygen. Whereas our rice, 1 rice grain might not weigh the same as another rice grain, just because they're not completely identical. So in our lab, we had some estimation still between our values. When we get into our chemistry, we can do some more exact numbers, just because we are comparing those values, and all of your oxygen molecules are going to be identical to all of the other oxygen molecules, as long as they're O2. All right, I hope that was helpful. Go ahead and write a summary now, 2 to 3 sentences for how our relative mass compare to the periodic table. I would also like you to finish off goal 1. So it does say use experimental data. Use the data that we figured out in your lab. Give me numbers. Compare the results that you got. So those are the 2 things to wrap up today. Awesome. Have a great rest of your day.